Okay, so at this point I have cut around the cornea and I have removed the anterior segment so that we can start to look at the structures inside. The first thing I want to point out is this right here. This, ooh, and vitreous humor comes with it. This right here is the lens. Okay, try to clean off the rest of the goop off of it. The lens. Okay, so that's it'll look kind of like a marble, but in real life it's much more stretchy, much more flexible, I should say, so that it can stretch and round up in order to change how much the light is refracted in order to focus onto the retina. Okay, so let's do the anterior segment first. So usually in real life that lens would sit right here and it will be attached to the eyeball, kind of floating, like suspended to the ciliary body. So if you look carefully, look at texture on your ciliary body, you'll see something that looks like the underside of a mushroom. That is going to be the ciliary body, and that is where the ciliary zonules, which are the little suspensory ligaments that will hold and connect to the lens, sit. And again, it'll just sort of suspend it kind of like that, so that as the light goes through the cornea, through the pupil, it'll hit into the lens behind it like that. Okay, so the ciliary body is this, again, the structure that looks like the underside of a mushroom. That's the ciliary body, goes all the way around. And then anterior to that is going to be a little flap. That is going to be the iris. What's the function of the iris? So the iris, what it does is it controls the amount of light that enters the eye by using, it has little muscles in it, and it'll constrict or dilate to change how much light goes in. Now, one thing that's very interesting is look at the shape of the pupil. Okay, so again, a pupil's not a structure, it's a hole. It's a hole in the iris. For humans, the pupil is going to be round, and for sheep, it is a slit, like elongated. So that hole would be the pupil. On the other side, you can see the other side of the cornea, which is that right there. The flap is going to be the iris, and the mushroom-like thing is going to be the ciliary body, which will attach to the lens, which is this marble structure here. Okay, into the post, and again, the vitreous humor is that stuff, the liquid that's squirted out. Okay, so this used to sit here, but it came out when we opened it. So this is the posterior segment. We can see the vitreous humor, which is the thick fluid. What it does is it creates pressure that keeps the retina intact and pushed up against the choroid. Okay, so I'm going to try to gently pull the retina up. See this very, very thin, delicate tan membrane? That is the retina. It's very, very delicate. Isn't it strange? That's the retina. Okay, so I'm going to go ahead and take it out entirely because I want to show you the structure behind it. Okay, so we have the retina, which is where the photoreceptors are going to be found, the rods and the cones. And you'll notice that when you try to take the retina out, get a picture first, but when you try to take it out, you notice how it's kind of attached. Okay, see how it's really like sort of coming off and still attached to the back of the eye right there? That's the optic disc. And the optic disc is going to be where the cells, the neural cells, they're going to come together, so the ganglion cells, they're going to come together and they're going to form the optic nerve. Okay, so the place where the optic nerve exits the eyeball, that's going to be the optic disc. Okay, so because it's kind of gathering together and then exiting out through the optic nerve, that's going to be where the retina stays attached. Okay, so that spot right there is the optic disc, the blind spot. Okie dokie, and so the neural layer would be the retina, the next would be the choroid, and in humans the choroid is going to be nice and dark. This is where is the vascular layer, where you have blood vessels that are going to nourish the other cells. Okay, there's the choroid. And then the tough outermost layer that's kind of protects it and produces the shape and structure, that's going to be the sclera. Okay. Now the choroid for humans would be all black, but if you'll notice that when we look in the sheep eye, instead of being all black, it has a really shiny surface. Okay, that iridescent sheen, that's called the tapetum lucidum or tapetum lucidum. So tapetum or tapetum lucidum, that is that sheen right there, and what that does is it allows them to see better in the dark, because as the light goes through the cornea, through the pupil, refracted by the lens, it's going to kind of bounce around a little bit more. That'll activate more of those rods, and that'll make it so that it can see better in the night vision than we can, than humans can. Okay, so again, that's the tapetum lucidum. Again, you can pronounce it tapetum lucidum, and that is going to do for night vision, and is not found in humans, only in other animals, like dogs and cats and sheep. Okay, did I miss anything? Nope, that's everything.